Hello everybody, my name is Stefan Schmidt. I'm a principal architect at the Open Source Technology Center at Huawei. And today I want to talk about running an OpenThread mesh network with Linux as well as Zephyr. So we will start with a little bit of a motivation, which is always a good thing. And then we go into the blueprint I'm describing here and the integration work I've been doing over the past few months to get that all working nicely, and also do a dive into the technical background. So on the one hand, the OpenThread border router, a service running on the Linux gateway, and the mesh node, which is basically an application or something you run on the Zephyr node. All of this is going to be built with Yocto, with the Yocto build system. We're using different Yocto and Open Embedded layers for that. And then we go into the process of onboarding, so how you're getting your mesh node onboarded onto the thread network, explaining that a little bit more. And we will finish up with future work and a summary of what you have seen here. So motivation. So why I was doing that, or why I think that is actually a good idea, why I would not just go ahead and use a Wi-Fi enabled microcontroller and be done with it, basically. There's quite a few aspects to that. So one thing is that a mesh network is really helping you to have like a good coverage in, for example, your house or something like that, or your office or something, where not every spot is covered with Wi-Fi coverage from your access points. It also gives you a little bit of redundancy. So if you have like one path not working because one device has been running out of battery or like being disconnected from the power supply or something, so it helps you to go another path. So that is why mesh networks are quite interesting here. And also about the power usage. So one of the targets I had was like using my controller and being able to use that with a coin cell battery and having enough power to do that for at least half a year or something like that, to run on this one coin cell battery. Depending on how big the usage is and how much data you're transferring, that can run like a year or two something on a coin cell battery. And that's not really possible with Wi-Fi right now. They're working on more power efficient standards for Wi-Fi as well, but right now that's not really comparable. Also, something that is offering here is IPv6 end-to-end connectivity. So that means you basically can like send an IPv6 packet from your microcontroller through the gateway to some device in your network, or even to your cloud service or your provider or whatever. Like you have full end-to-end connectivity with IPv6, which in the end gives you a completely internet-enabled microcontroller, which is quite nice to play around with, and should give you a nice base for all your own experimentation and products and so on. So what are we using here? So we are using the OpenThread project. It's an open source project licensed on a BSD, and they're implementing the thread network protocol. So there are like two different things. So there's the thread group, which is like all kind of member companies. They are developing the specification, they're working on the testing, they're working on the certification as well. And you have to be a member to get like access to all of these things. The version 1.11 of this certification is also available for everyone. So it's not, you don't have to be a member for that or pay anything. But if you're a member of the thread group, then you're getting access to new specifications, being part of the working group and so on. But for all the things I'm doing here, you don't need to have any of these. You only need that if you want to bring out like a product that is built on thread and you want to be thread compatible and stuff like that. Then you might want to go through a certification, and then you need to be a member of the thread group. But for us, that's not really relevant here. But the OpenThread project itself, as I said, it's an open source project with a very active community. It's an active project, a lot of things going on there. Obviously, a lot of the people working there are coming from the member companies of the thread group, but also community people being there and just using it for their own purposes. It's a very versatile code base that can basically run bare metal on a microcontroller. If you have like a supported one, it can run directly on it. And it can also run on different RTOSes, so they support something like FreeRTOS or Zephyr, and I don't know what the status of the wired support is, and obviously also on Linux. And if you want to have a look, there's like OpenThread.io, they have like code exercises and stuff like that. So it's really interesting to get started. So, but what does OpenThread actually do, right? I mean, they're doing a mesh network on what? So they're building on top of different existing technologies here. So they're reusing the IEEE 802.15.4 specification. This has been developed since 2003. So there's existing silicon chips and transceivers and stuff like that. So that's all already available. Basically, all the Zigbee devices you might have or see in the wild, they are also using 15.4 as their radio. So this is like something widely available and cheap to get. And the other part of the existing technology they're using is 6LoWPAN, which allows you to use 802.15.4 and run IP version 6 on top of that, which is not so easy because the frame sizes from 15.4 are not really suitable for IP version 6 normally, but 6LoWPAN has some kind of technologies to like have like header compression, stuff like that to make that possible. There's some slides in the appendix. If you download the slide set, you can look at that and see what's going on there, how that is possible. And that is another existing technology they're using. And what OpenThread basically does is filling all the many gaps that are available to make that a turnkey solution. So none of the existing specs is defining how you do like the mesh network management, how you do like making sure that the keys are deployed securely over the mesh network or keys getting rolled over and all this kind of stuff. It's not defined in any of the other specs. And OpenThread is really pitching in there and like filling all of that and making it a turnkey solution you can use for your projects or your product. So what I've been doing was in the ONIRO project, we have this idea of we wanted to have a blueprint for a modern IoT gateway. A gateway with modern technology, basically. So we don't want to go ahead and just implement what's already out there, like Zigbee and stuff like that. We wanted really like a forward-looking thing, and that is where OpenThread has been interesting for us. So the idea of an ONIRO blueprint is basically to aim for something like 70% of the work done towards a real product. So you can really take all the stuff we have been doing here, doing the rest of the like 20 or 30% and ship a product with it, or build a project for your home, or just hack around on it. So that's like, we want to have like quite a high bar here into what we're releasing. But we also wanted to use off-the-shelf components to make it easy accessible for everybody to just toy around and play with it. And we are giving like a hardware bomb, we're giving documentation, videos and stuff like that. And obviously all the source code and stuff like that is available as open source. So we have like two components here, two main components. That is the gateway, which is running Linux. That's basically a standard Raspberry Pi board. And you would need a micro SD card. We are using an 8 GB size here because we are using on ONIRO. We're having like A/B partitioning to allow over-the-air updates and so on. And then you would need like a USB dongle or something that is providing a thread radio interface, because Raspberry Pi doesn't have any radio capability for 15.4 or thread. So we are using a USB dongle here, which is from Maker Diary. Yeah. And on the mesh node side, we have been choosing an Arduino Nano, which is using a Nordic chipset. They have support for Bluetooth and Thread as radios, which are already built in and so on. So we don't need any extra radio or transceivers added to it. And with 1 MB flash and 256 kilobyte of RAM, that's more than enough for our use case and so on. And another component that is not really completely necessary, but part of the blueprint we are describing here is an Android mobile phone to run the onboarding application, the commissioner. I will talk about that a bit later. So what kind of integration work did we actually do to get this blueprint working? So because, I mean, the OpenThread project is already there. It's not like we started it or something. So we needed to make sure that we can fit into our ideas and our use cases here. So we are building everything with Yocto Open Embedded for Linux as well as for Zephyr. So the first thing was to start to like build all the receipts we need for the different components here. So OTBR POSIX is the OpenThread border router. POSIX for Linux, and this is for the POSIX, to actually be able to run as a server, a systemd service, so you can run that on the Linux side. OT daemon is like an OpenThread daemon, which is basically turning your Linux machine into just another mesh node, so you don't have any special capabilities or something, and then we have some other utilities we packaged here. This is all sitting in the Meta ONIRO staging layer. Staging for us means here that is all the work that we still need to upstream. We're actively doing that, but not all of the things we have been doing so far has been upstreamed. That's all work in progress. We also needed to write some systemd unit files, make sure that all the interdependencies are handled correctly, so that the out-of-the-box experience for this blueprint is nice and working well. Also, we need to do like some scripting for the default configuration, again for the out-of-the-box experience, to make sure that all the network settings are set up correctly and OpenThread is set up with all the network keys and so on. That is, once started, everything is working smoothly. That is more like integration work that is sitting in a different layer, Meta ONIRO blueprints, where we do like the integration work for the blueprint, and that is sitting there. We also needed to do some upstream fixes here and there. For example, like muscle build problem is on OpenThread and so on. That's, I mean, nothing too big or so, but obviously work you have to do because we're building this muscle. But that all have been upstreamed, so that is all done already. On the Zephyr side, we have been choosing a device that is already supported. So that was a good start. Still, we need to do some sort of hardware enablement and also writing the Zephyr application to actually tie all the pieces together of the configuration and then getting flashed on the device. And again, we have been working on documentation to make sure that it's all clear and hopefully easy, accessible for people to understand and reproduce. And there's also a demonstration video showing this whole thing in action, what's going on and how it fits together. Okay, so going into the technical parts here. So, as I said, the OpenThread border router, that is a service, a systemd service, which is basically running on the Linux side. So that is the code coming from OTBR POSIX. And you need to have like the thread radio, that's the USB dongle I described earlier. You need to have that to have like the actual physical capabilities to speak to a thread network. So we packaged, we did a package for that on Yocto. We worked on the systemd files. That is all working. We have a configuration script. You can see on the right side an extract of that. So you can see like in the beginning, we are making sure that everything is like cleared down. The data set is clear and so on. Then we are starting fresh and setting the PAN ID and a network name, for example, the channel and stuff like that. You see like two passphrases here. One is for the commissioner credential and one is the joiner credential. So the commissioner is the one you might need to enter on the Android application when doing the first onboarding of a device. And the joiner credential, that is something shared between the firmware of the device as well as the QR code that is used for the onboarding. I will explain about that a bit later. Yeah, and then you have the usual thing you need for like your Linux router or gateway or something like that. We have like forwarding on the interfaces, and then we also start up a Wi-Fi access point service to allow the mobile phone for the onboarding to directly connect to the gateway and so on. Yeah. If you want to explore this OpenThread system on Linux, I really highly recommend using the OTCTL command. It's giving you a shell and can have like all kind of help going on there, and you can explore the system and see what's going on and how the things are fitting together. It's also giving information about existing routes, existing childs and mesh nodes in the network and so on. That's quite interesting. The same on the Zephyr side. So as I said before, we picked a board that is already supported. We still needed to do some parts of enhancements. So for example, OpenThread on Zephyr needs a storage partition for like permanent storage of network information and so on. So you need to make sure that that is working. We also need to do some fixing to get a USB serial console to have like access to the device and configure it and debug and so on. And if you write an Zephyr application, there's like two main parts to that. So one is the project conf, which is basically the kconfig. So you can again see an extract on the right side here. And that is describing how the whole configuration of the kernel and all the different modules and subsystems is done for this specific project. And then the application itself is like a normal C code where we have a main function and stuff like that. For us, it's completely empty because for our use case, we could configure everything we wanted to do, like, for example, auto-joining an existing network and stuff like that. We could do that on the kconfig level. You can see that on the right side. If you look at the bottom a bit more, you can see the network name. It's the same we had on the Linux side. You see the joiner equals J, so that means you're like, yeah, you have a joiner enabled and it's auto-started, and you're using this pre-shared key for the joiner. Don't confuse that with a network key or something. There's nothing encoded in the firmware that would export your network key or hard code your network key or something like that. That's completely different. That is just for the onboarding process of the device. The network key itself never leaves the network on OpenThread level, but that would go too deep here and not really help in this time frame. And again, you could explore the system, getting a USB serial console on the device, for example, here the screen, and then have the OT command, which is the same as the OT-CTL command you see on the Linux side. You can have like help and then go explore the system. We are building that all with Yocto Open Ballot. We have that all packaged together with a manifest file for the ONIRO project. So you would only do the repo in it, get the manifest file, and then sync all the repositories. And you would have all the things set up correctly for you. Obviously, you can also go ahead and take the layers we are providing and take them to your own system or your own distribution or stuff like that. So that would also be possible. But if you want to go with the ONIRO project wrapping we have here, it would be as simple as initializing your build environment with the OE init build-end script and using a template conf for the Linux flavor. As I said before, we are building for Linux as well as Zephyr from Yocto. So that means we need to define what kind of flavor we want to build here when doing the initial setup of the build directory. And then for the building itself, you basically set the distribution, the machine, and then the image. And then you can go ahead and flash it on an SD card for the Raspberry Pi and get it booted. On the Zephyr side, it would be very similar. As you can see here, you have like the flavor would be Zephyr, and to make sure that that is set up correctly. And then again, setting the distro, the machine, and the image type. On the Zephyr side, you can also use bitbake with the flash command to actually flash the firmware image onto the device. It's all wrapped nicely in bitbake, so you don't have to go around and look how to flash the device, for example. Yeah, now about the onboarding. So all of these pieces are nice and give you like a good idea how you can get like device on your network, but how you really do that, right? I mean, and in an aim to have like a kind of 70% ready product already, having a turnkey solution for the onboarding is also quite nice. And that is what Thread is offering us with the Thread commissioning app that is available in the Android App Store. You can install that. And then for the device itself, you need to make sure that you have a QR code ready. You can also enter the credentials manually, but it's way more convenient to do that with a QR code. So if you create a QR code with the mysteric line on the second line you can see there, which is basically saying nothing else than version 1, just versioning, so nothing important here. The EUE, that is the MAC address of the device. That is something you would need to, it's unique to the device you want to onboard, and that need to be specific in the QR code. And then you have the joiner credential, as I said before, that is like hard-coded in the firmware. And when the commissioner tries to onboard the device, it would use this part of the QR code to do that. So you would need to create this kind of QR code And then when you want to onboard your device, you would start the thread application. It would find the thread border router, which is announcing itself over MDNS. So it would find it, and then you select it, and then starting to show you a camera view to scan the QR code. If you do that, it tries to onboard the device, and at that point you would start the Arduino Nano or reset it or something like that. And then it tries to do the auto joining during boot up, and then the process would finish. And as you can see on the right side, it would basically end with like a MyThread product being in. At that point, it means your device is on the thread network, has an IP version 6 address, has connectivity to the gateway, as well as to the wider internet if the gateway is configured correctly for that. And you have like everything ready to deploy your own logic on the microcontroller to have like whatever sensor or whatever IoT device you want to build. So that's all there. But yeah, I mean, that is the first iteration of this blueprint we have been working on. There's more to go. So our future work's mostly looking like this. We want to update the OpenThread version. The one we are using is a bit dated, so we need to use a newer one, catch up on the changes and so on. We're also looking into integrating the Meta protocol, which is a modern IoT connectivity standard, which is currently worked on. It's not fully specified yet, so that's why it's not integrated, but that's something we are looking forward to do as well. We need to flesh out the whole IPv6 connectivity story to make sure if you have either IPv6 native connectivity at home or towards your gateway, or only version 4, and then you would need to do some net or some tunneling or something like that. This need to be working out of the box as well. I was also looking to use another Arduino Nano as a thread radio, so we only have like two hardware components basically, and don't need the dedicated USB dongle or something like that. Yeah, so I have a personal interest to get like the Linux WPN platform running, have that as a platform for the OpenThread border router. I will see when we have time to look into that actually. And yeah, a simpler workflow for the built-in flashing for the border router radio it's a bit annoying to do right now, so that would be good to be improved. So what is it what you should take home here? So what this is offering you is like really a turnkey solution for like getting some kind of microcontroller or sensor on a wireless link, and even with a really small power budget. So really take your microcontroller, put a coin cell battery to power it, and have it running there and being able to do like the wireless communication for like sensing or acting or whatever. And that should really give you a kickstart to do all that, to deploy your own logic on top of a normal IP connectivity. We're offering both gateway as well as mesh nodes, so that both sides are covered here, and all of this is obviously open source and ready to be hacked on. It's all public already. There's nothing waiting or closed or anything. You can go ahead and try it out right now. As I said, it should be a good start for you to build your own software on top and everything on top of the transport layer that is already provided here. So if you got interested, there's like 2 QR codes here. One is for the demonstration video to show how's it working, how I demonstrate how all the pieces are fitting together, and then also a link to the documentation that should get you started to try this out. Yeah, thanks again for listening. So if you want to check out other things from the ONIRO project, there are some talks here in the embedded room, but also on other rooms at FOSDEM. You can also visit the ONIROproject.org page. It's an Eclipse Foundation project with different member companies and so on. Okay, thanks a lot. Have a good day.
I have one question. Somebody asked whether the gateways can be meshed as well.
Yes, so basically you can have like several gateway components if you want, and like one being the leader of the mesh network, and then you can have like different entry and exit points of the mesh network. So it could be part as a normal router of the mesh network, and only when one of the other ones is like being powered down or like something else happens, then it takes over the lead. So you can have like different entry and exit points.
That's another question. So is the West built infrastructure from Zephyr reused or replaced by ONIRO's infrastructure?
When we started, we actually didn't use it with Meta Zephyr, but just recently, over the last few weeks or something, some colleagues of mine have been working on using West within the Meta Zephyr layer. So this is something, so we can actually reuse it for like finding the different modules, what is available in Zephyr and so on, as well as generating hardware targets, boards, and so on for the Meta Zephyr, so we can build it for all kinds of devices and so on. So that is like being upstreamed right now. I think that's already in Meta Zephyr upstream. So it's using West heavily by now, yeah.
And there's another question from Tim. Do you know if you can easily run a gateway on OpenWRT, since many supported devices have USB, and this seems like a nice gateway platform?
Yeah, I think there have been work on getting OpenThread running on OpenWRT. I've seen something like that. I'm not sure if there are packages for that inside the official OpenWRT systems or not, but I have seen people doing that. So that is definitely possible. I mean, it doesn't really have many dependencies on a system level, and as long as you have like a USB device or some other possibility to get a thread radio connected, could be SPI or something like that as well. Then it should definitely be possible, yeah.
Okay, so Andre confirms that the patches were merged lately.
Okay, thanks, Andre. If you have a second, so these Linux WPAN, that is the Linux kernel subsystem. And if we find a way to use that in OpenThread, we would be able to expose all the device drivers you already have. So that is why I'm looking forward to have something like that maybe.